Okay, I am asking for the solving quadratic practice that we did last time to be turned in. And quite a few of you already did that in Google Classroom. I think I opened it up after I saw you, but I guess you guys got the email or whatever. So if you didn't put it in Google Classroom, please make sure your name's on it and come put it in the basket before we get started here. I'm gonna need just a second. Gradebook is very slow right now, but I need to get attendance put in. Alright. So we are going to spend one more day reviewing some more quadratic stuff. And then Friday we will have a short review on what this unit is going to test you over. So the stuff that we did from section 1.1, which was linear and piecewise stuff, will be on your next test. Solving quadratics with factoring and quadratic formula will be on your next test. And then the last new thing that we will hold you accountable for is some quadratic function analysis, which is mostly about graphing. So the handout you guys should have picked up is 106. So let's go ahead and review some of that, and then there's like a, I don't know, like 16 question book assignment for you to get some practice in on that. Yeah.
Do you have it up there that B-Day is taking the test on the 21st?
What's the 21st?
My teacher is taking it today. It's the day before prom.
Okay. I'll have to change it later. That's for B-Day anyway, so. But thank you. I will try to remember that. Okay, so part of what you guys need to get out of this is this is a little bit less organized here, because you could really kind of tackle these questions in a lot of different orders, and the order that I might think to do them in may not be the easiest for what you think to do them in. But basically there's two questions. Question one has a function and asks some things about it, and then halfway down the sheet you got a different function and asking the same things about it. So you need to use this as some notes here and follow along with me, and most importantly highlight the stuff and the formulas that you don't remember, because that's the stuff that you need to relearn. So this is what we call standard form. To make it a little bit confusing, standard form can mean different thing to different people. Your textbook actually calls vertex form standard form, but this is what most people refer to as standard form. When you have it in how many x squareds, then how many x's, and then what's your constant. So the good form for quadratic formula. So we should be able to write it in these other two methods, in what's called vertex form and factored form. Each one of these three kind of have their own strengths. So we want to say the exact same thing. We're not changing the way the function looks or the size of the function, but we need to change his appearance. But part B is going to be the easier one, I think, because factored form just means basically factor it. So I look at that and I notice that there's a GCF and you should always factor out a GCF first. And then it looks like I could get the rest with guess and check, but of course sometimes you might need to get product sum or some other factoring method, but for factoring form you need to factor. Now, one of the biggest benefits of this method, well, let's start with this one. One of the best things about this standard form is, I would say, y-intercept. Y-intercept is very easy to solve for if it's in standard form. Since all y-intercepts have an x value of 0, if I plug in a 0 here and a 0 here, 0 minus 12 would be negative 12. Now, in theory, you could also plug in 0 over here, and it's not that it's that much harder. In fact, it better be the same thing, because again, we're changing the way this looks, but we're not changing its size. 2 times negative 3 times 2 would be negative 12. So you could plug it into either, but this one tends to be a little bit easier. Whereas factored form tends to help quite a bit with x-intercepts, because x-intercepts are when y equals 0. So you just set each one of these factors equal to 0 and solve. 2 doesn't equal 0, so that doesn't give us 1. But x minus 3 equals 0 at 3, and x plus 2 equals 0 at negative 2. So that's one of the benefits why we like to write it in factored form. Whereas vertex form, this one's going to take a little bit more work, and this is the one that students are usually less familiar with. Vertex form is going to be great at showing us the vertex and letting us know the max and min of the function, and also the line of symmetry pretty quickly. So there's a couple ways you could do this, but the first way, and I'll make a second connection for you, but you absolutely have to know what your answer is supposed to look like. That is what vertex form looks like. So within this, there's 3 numbers we have to replace: A, H, and K. A is actually the same A as over here. The same A as when we talk about quadratic formula. That's why they can use the same number there. So that should be a 2. That's the easiest part. H, K paired up as a point tells you where the vertex is. So the vertex is the maximum point of the parabola or the minimal point of the parabola, depending on if it opens up or down. But to find H, and I don't know what it is about this formula, but students don't do a good job of remembering this one. H is opposite of B over 2A. In fact, that should sound familiar to you. Remember this formula that we used a million times last class? Quadratic formula? It's just this part of it. It's the far left part. Gives you the x value of the vertex. So for us, if we did opposite of B, that would be 2, divided by 2 times A, which would be 4. So negative 2 divided by 4 would be negative 1/2. And minus a negative becomes plus. So that's one way to find H. There is a second way, but I will tell you in a few minutes. And then for K, the y value of the vertex, well, that's going to come about like any other point. If you want to know the y value of a point, you should plug in the x value. So we got negative 1/2. You need to plug in the x value into the function and solve for y. So for this one, this would be 2 times negative 1/2 squared, which would be 1/4, minus 2 times negative 1/2, and then minus 12. Yeah, looks good. Okay, so this would be 11 or negative 11 plus a half, negative or 10 and negative 10.5. Does that sound right? Okay. So like this also is one thing that is a little tricky for students, but it's the same way you find any other point. Way back in Algebra 1, pretty much the only way you found out what a graph looked like is you picked random x values, you plugged them into the function, and you solved for y, you plotted the point. Well, in this case, we're throwing in not really a random x value, we're throwing in the x value for the vertex into the function, solving for y, and that would be the y value of the vertex. Looks like negative 10.5. Okay, so the purpose of vertex form, the reason why it's popular, is if you know how to read this, you can get the vertex out of this in about 3 seconds. The vertex is hk, and notice h is the thing you subtract from here, but k is the thing you add from there. So the thing I'm subtracting from h is negative 1/2, and the thing I'm adding to the function is negative 10.5. So it's like opposite of this, but then not opposite of that. Now what the vertex tells me is it tells me when the max or min occurs and what the min or max value would be. So that is part F. This guy goes down as far as negative 10.5. Okay, and then we could have done E at any point, but if you don't remember whether a parabola opens up or down, you need to add some notes over here. When A is positive, that's when your parabola opens up, which means your vertex is a minimum. But if A is negative, your parabola gets reflected over the x-axis and opens down, and then the vertex becomes a maximum. Since A is positive in this question, I know that this is a min. It goes down as far as negative 10.5. Okay, let's go ahead and start putting some of this on a graph over here, because then line of symmetry is a little bit easier to see. Now you do have to be a little cautious here. I think if you center this in the picture, you're not going to have negative 12 to go down. So your graph doesn't have to look block for block the same way as mine, but that's why I'm not centering it. So we can plot the y-intercept. Wait, hold up. There's definitely an arithmetic mistake on here. If our vertex only goes down to negative 10.5, that's supposed to be the bottom point. So how's it getting to negative 12 there? There's my problem was with H. Opposite of B would be 2 over 2 times A. Right, so H was supposed to be positive 1/2. So this makes this minus. That makes more sense. And so then I should have been plugging in a positive 1/2 here, which is going to change this a little bit. The nice thing about doing so many parts of one single quadratic is, again, all of this needs to be consistent. None of this stuff should overlap with each other. So this looks okay, but this should have been positive. So this is actually a minus. So negative 13 plus 1/2 would be negative 12.5. Negative 12.5. Negative 12.5. And then right here, negative 12.5. Okay, do you see how that makes a lot more sense? The vertex has to be the biggest or smallest point. There's no way the y-intercept just happens to be smaller or bigger. That doesn't make sense. So that's how I knew I had an arithmetic mistake. Okay, but we've got the y-intercept plotted. We could also plot this vertex. So when x is 1/2, it goes down to negative 12.5. We also have these x-intercepts we could throw on there. 2, 3, and negative 2. Okay, the next piece, line of symmetry, is also going to be the way that you can also have a second option to find the x value of the vertex. So I guess I could have caught it here in just a second if I had kept going. Your vertex is the very middle of your parabola, and your parabola has line of symmetry to it. So there's this line that's this invisible line that's cutting our parabola in half. He is a vertical line, so his equation is x equals, and he has to go through the vertex. Now, I already know the vertex is at 1/2, so all I have to do is copy that down. But a second way you could find the x value of the vertex, if you don't like this negative b over 2a, or if you forget it, is notice the vertex has to be in the middle of these two x-intercepts. Between 3 and negative 2, the number in the middle is 1/2. So that's a second way to find the x value of the vertex. Also, because of this line of symmetry, so this point could reflect over the line of symmetry and land here. That's not real helpful because I had that point anyway. But down here, the y-intercept could flip over the line of symmetry and give me a fifth point. And now if I've got 5 points, I can connect those, make it look like a parabola, and part I is finished. Our graph looks pretty good. Alright, and then the rest of the questions are quite a bit easier in my opinion. For those of you doing calculus next year, we spent a lot of time talking about when functions are increasing and decreasing. The big difference is in calculus, we learn calculus to figure that out, and we don't have a graph to look at. So without looking at this graph, we would try to describe that stuff. But increasing just means where's the graph going up, and he starts going up when x is 1/2 and continues to go up forever. Decreasing just means when is the graph going down. So it starts going down from the far left and it keeps going down to 1/2. Now notice, I could care less how far it goes up or how far it goes down. I care about when is it going up, when is it going down. We're talking about x values here. And then constant is when your graph is flat with no slope, and that doesn't happen here. So that doesn't apply. So the 30-second recap, and then we will do it all again with the second function. But factor to get factored form, that helps us with x-intercepts. The standard form is pretty easy to solve for y-intercept. Just plug in 0 and solve. Vertex form, you have to find a, which is the same as this a. You have to find h, which you can use this formula. Just be careful with the arithmetic, because that's what I did wrong. And then you have to find k. K is the y value of the vertex. So you plug the x value of the vertex into the function and solve for y. Vertex form is great at giving you the vertex. Because a was positive, it opened up, which means the vertex was a min. I didn't correct this. That min value is negative 12.5. The vertex is telling you the highest or lowest point depending on which way it opens. The line of symmetry is supposed to cut your parabola in half, so it goes through the vertex. Plotted our x-intercepts. Increasing is when the graph's going up, decreasing is when it's going down, and constant is when it was flat. So before we look at a second example, any part of that you'd like me to speak on again? I'm assuming you did most of this last year at some point. Okay. Alright, so let's do it one more time from scratch before I ask you to start trying some of these in the book assignment. So again, you can really start in a lot of different ways on here. Like the fact that I have standard form means I could get the y-intercept very quickly. 0 plus 0 plus 8 is 8. But to get vertex and the min and max value, I probably would like to see vertex form, so if I've got to do that anyway, I'm probably going to do that first. For the x-intercepts, I'd really kind of like to look at the factored form. So I'm going to, it's optional, but I'm going to factor out a negative. You don't have to factor out the negative, but it does make it a little bit easier. Now, if something doesn't factor, I think this comes up in 1 or 2 of the book questions, you can still find x-intercepts with quadratic formula. Quadratic formula always works. Factoring usually works, but not always. If it always worked, we wouldn't need quadratic formula. So set the factors equal to 0 and solve. -1 doesn't equal 0, so that doesn't give us 1. X minus 4 equals 0 at 4, and x plus 2 equals 0 at -2. So quick and easy x-intercepts if you have the factored form. So that's his strong suit. Okay, vertex form is where we have to make our answer look like this. So it's almost like you have to memorize the formula to know what your answer is supposed to look like. You have to know that there's 3 numbers that get replaced in here, A, H, and K. A is the easiest one because it's the same as this A, the same A you would use in quadratic formula, -1. H, one way to find H, besides the graph, which we can confirm with later, is to use -b over 2a. Now, since this was my arithmetic mistake earlier, I'm actually going to write it down and be a little more careful this time. Opposite of b over 2 times a, that looks like that is 1. Now the form says x minus h, so if h is 1, you need an x minus 1. This sign is opposite of what you might think it should be. The vertex has an x value of 1. The y value comes from plugging the x value into the function and solving. So you should be able to plug that in here or plug that in here. Should be the same number, so it shouldn't matter. I'll just plug it in here for something different. If I plug in 1 here, I get -3. And if I plug in 1 here, I get +3. Looks like in the end, +9 plus 9. So opposite of this, not opposite of that, pair up and make the vertex. Okay, to know if the vertex is a min or a max, I should think about whether this opens up or down. If A is positive, my parabola is going to open up, which makes the vertex a min. But in this, that's what happened in our first question. But since A is negative, my parabola is going to open down, which is going to make my vertex a max. And then part F, I've already done this, you just have to make this connection. Vertex, the biggest value is 9, it occurs at 1. But part F is asking what is the biggest value, or smallest value if it was a min. The line of symmetry needs to be a vertical line that goes through the vertex. So to go through 1, 9, his equation needs to be x equals 1. And then if we throw all of this stuff on a graph, everything should be consistent and make sense. If something's wrong, it's going to kind of stand out, or it should stand out quite a bit. So plot the y-intercept, plot the vertex. Give yourself a little visual of the line of symmetry. Any points you have on the left of the line of symmetry should flip over and give you another point. So I knew the y-intercept, I can flip it over and get this point as well. We also had the x-intercepts, 4 and -2. Now notice those two should both be equidistant from the line of symmetry as well, and the fact that they are is a great sign. And since now I've got a graph with 5 points, I would say that's pretty good to get a pretty nice looking graph. course, more points is always better, but 5 points is pretty good. And now that I have that in front of me, I can describe when it's increasing. It's increasing from the far left until x gets to 1. I can describe when it's going down, decreasing, starts decreasing at 1 and then forever to the right. And constant is anytime the graph is flat. That doesn't happen in parabolas, so don't leave it blank because that makes it look like you don't know the answer. Say none or not applicable. But if one or more of those things was incorrect, then it should stand out and not be consistent with everything else. Everything kind of has to fit into place. So sometimes answering a bunch of questions about one quadratic function is kind of nice for that. Okay, so I hope that you remember all this. I hope that you guys practiced a lot of this last year. I've not taught Algebra 2 in years, so I don't know how much time you spend on this. I don't know if you spent 2 months on it or if you spent 2 days on it. But I do know that some of this you haven't used in a while, so it should be a good review anyway. But our next piece is, again, there's like a 15, 16 questions, I think, out of the book assignment. So if you would go ahead and copy those down, please. And then if you didn't pick up a book on your way in, you will need to go get that. You also need a calculator for a question or two. So you might get that. And you want to aim to get as much of that done as you can in class. So every 10 or 15 minutes, I will check in and give you a chance to ask some questions. And if there's some questions at the end that you end up having questions for that you don't have class time for, I will take those next class. But next class is basically the test review of this little mini unit. This is the last of the new stuff in this unit. Or at least new to us. This shouldn't be new to you, but new in our class. Sometimes Gradebook just doesn't save it if the internet goes down. So. Okay, it's only been about 11 minutes, but any of the first few questions you've tried that you'd like me to go over and help with? I'll check back in a bit then. Okay, checking back in. All right, we got a few I can help with.
25.
Number 25. Okay, if you think you might need help with 25, you might jump ahead to that one. Let's see. Okay, so they say write this in standard form, which I'm going to call this good because this is what I would refer to as standard form. I bet if you check in the back of the book, though, they probably put it in vertex form. I think that's probably what they mean by standard form. Again, standard form can mean different things to different people, but I'm good with that. Identify the vertex. Axis of symmetry, which is the same as line of symmetry, and x-intercepts. Okay, for x-intercepts, for me, I can get that information quickly from factored form. So I would try to factor this guy and then figure out when y equals 0. And I don't know that it factors. I might have to do quadratic formula here, but let's see, 21. Okay, so if I can't see how to factor it with guess and check, my default is to think about this product sum method. A times C is 84, B is -4. So if I can think of two things that multiply to this but add up to that, then I can do it that method. So 1 and 84, or both negative, but that doesn't help. 2 and 42, or both negative, those aren't going to add up to -4. Could double this one, which halves this one. If both those are negative, that doesn't add up to -4. I can make this, take out a 3 here. Should look like that. So 7 and 12, or 12 and 7. If they're both positive, they don't add up to -4, and if they're both negative, they don't add up to -4. So the fact that nothing multiplies to 84 but adds up to -4 tells me that this does not factor, which is unfortunate, but the nice thing is we just recently reviewed our backup plan, which would be quadratic formula. So opposite of B plus, honestly, this isn't necessarily longer than doing this in this case. So opposite of B plus or minus B squared minus 4AC all over 2 times A. Okay, normally I would try to do that without a calculator, but that's 4 times 4 times 21 is going to be pretty big. So I'm just going to ask it to do the whole discriminant for me, which would be -320. Now I'm actually going to quit here. I'm not going to simplify this like I made you do last class, because the fact that the discriminant is negative means that our solutions are going to be imaginary, right? Even without simplifying it. And imaginary solutions don't show up on a graph, so they don't show up as an x-intercept. So I know this is never going to cross the x-axis. I know it doesn't cross the x-axis because his only solutions are imaginary. Real numbers, when you think about graphing, it's only real numbers. There's no I on a coordinate plane. Okay, but I could have broke that down more, but I don't need to because I just want to know the graph characteristics. So vertex, I could get the first part from the opposite of B over 2 times A, which would be 1/2. And then to get the y value of that, I need to plug in that x value into the function and solve. Okay, I guess I can do that by hand. 4 times a half squared would be 4 times a fourth. So this would be 1 minus 2 plus 21. So 22 minus 2 would be 20. When x is 1/2, y would be 20. And then finally, the axis of symmetry / line of symmetry, same thing. It's always going to be a vertical line, so x equals a number. And it needs to go through the vertex to cut it directly in half. So for this question, it needs to go through 1/2. X equals 1/2. And then of course, I cheated with the calculator just a little bit for arithmetic, but also graphing this in your calculator real quickly to see that it doesn't cross the x-intercept, to see that the vertex is this. You're going to have to play with your window settings and make them go up a little bit to see that. But you could do that, and then you could see that the line x equals 1/2. Divide your graph in half, so you could get some confirmation that way. But anybody have anything specific about this one before I let somebody else ask? Okay. All right, does somebody else have another one or two? Yes, Harper. 51. Okay, use a graphing utility to graph the quadratic formula. Find the x-intercepts of the graph and compare the solutions with the quadratic equation when f of x equals 0. Okay, so for the first half of the question, they're saying, why don't you graph the equation x squared minus 4x so that you can see where the x-intercepts are, 0 and 4. 0 and 4. And then compare them with trying to solve this by hand. So x-intercepts are always when y equals 0. And like we talked about last class with the solving of quadratics, technically you could use quadratic formula here because quadratic formula always works on quadratics. However, factoring is going to be much quicker. You could factor out a GCF, set this factor equal to 0, he's already solved, set this factor equal to 0 and solve. And then notice you get the same two answers as that you see from the graph. So they're just trying to get you to see the visual versus the algebraic. Two different ways to see the same thing. Of course. Okay, anybody else have another one ready? Okay, I will check back in one more time then in about 8-9 minutes to make sure that we have time to work what you get to. Again, if there's a couple you don't get to at the end of class that you end up needing help with, I will give you a chance to ask about those questions next class, but all the stuff from the early part of the assignment should need to ask those for sure. got about 12 minutes of class, so if you guys have a couple more you'd like to ask, we need to get those in, otherwise there won't be time for me to go over them. So, is there another question or two I can help with? 41? Sure. Let's see, 41 gives us a vertex and a point, and asks us to write the standard form of the quadratic whose graph is a parabola with this vertex and passes through this point. So on this one, it does say standard, but again, I believe, and you can correct me if I'm wrong, but standard, what the book refers to as standard is actually vertex form. Did you check the answer in the back? See it? Okay, they have it in vertex. Okay. So, the easy part of this question, well, you do have to know what vertex form is supposed to look like. Don't forget to square, by the way. That's a very common mistake. If you don't square it, it's not a quadratic. But plug in 5 for h and 12 for k. And remember, it looks like this one looks opposite of what it's supposed to be. -5 gives us +5, and this one does not supposed to look opposite. So make sure that you have that distinction. So the real, I guess, mystery to this question that doesn't make it just where you could almost go straight to the answer if you have this memorized is trying to find this a value. So what we can do though is we can use this point and temporarily plug in 15 for y and temporarily plug in 7 for x. And what that's going to do is give us an equation that all we're missing is a. So if we finish solving this for a, we can go and plug that in back up here and we will have our answer. So we could subtract 12 from both sides. I could subtract these and square them. That would be 4. And then divide both sides by 4. It looks like a was supposed to be 3/4. So in the end, 3/4 x minus 5 squared plus 12 is what I'm guessing they're looking for. So sometimes you have to do that to solve for a. You have to plug in the vertex for h and k. You have to temporarily plug in the point for x and y. And then that gives you an equation that only has a in it, so you can solve for that and then plug it back in. Okay, anybody else who was going to ask about this one have anything about it before I take it away? Okay. Alright, is there somebody else that had another one? 35? Alright, 35 is really not too much different than the one that was just asked. It's just the information is kind of presented in a different way. But notice they give you the vertex. So if you know what vertex form, what they're calling standard form, is supposed to look like, plug in the x value of the vertex in for h. So if h is -2, this becomes a -2 or a +2. And then k is out here. Remember, opposite of this, not opposite of this, is supposed to give you your vertex. Then, the only thing keeping me from circling this as my answer is I don't know how big a is. But they do give you another point. So just like the last question that was asked, you can temporarily plug in that x and that y to solve for a. And then once you know what A is, you can go back up here, plug in that number. Of course, if it's a 1, I don't need to write it. And then that would be your equation. And if you had a calculator, you could graph it and confirm that it looks like the graph that they gave to you. Okay, you guys got about 6 more minutes, so try to get in another question or two before you find a stopping place here. Again, I do need you to finish practicing the rest of those on assignment 107. So that way, if there's 1 or 2 of those at the end that you're struggling with, you at least know to ask about them next class. I'll give you that opportunity, and we will have a review worksheet. I don't have that printed out yet, but it is on my website if you would like it early for some reason. And so we'll do those 2 things on Friday. Next Monday is ACT Aspire Day, so I will see you guys in the afternoon, but only for about 10 or 15 minutes. So we won't do anything new then, and then we will do this small unit test on this time next week, next Wednesday.